that is speed. Okay, let's start our discuss. This is the average speed. Average speed. So, what was average speed? Right? So, there is the definition for average speed, what we have discussed earlier. Right. So, generally, people will be saying speed, speed, speed of the object. So, they actually, there is nothing like particularly speed. Actually, speed we have three types. That is, one is average speed, either it should be average speed, or the second one, it should be uniform speed, or third one should be instantaneous speed. So, what are they? Totally, first one is either should be average speed or uniform speed or instantaneous speed. That means once you say the word speed should fall among either of these. Okay. Once you are speaking speed, it means there is nothing like speed. Okay. There is nothing like only simply speed, but it should be either average speed or it should be uniform speed or should be instantaneous instant instantaneous instantaneous speed. So either it should be average speed or uniform speed or instantaneous speed. So we have discussed already average speed. Let us see what is uniform speed now. Okay, suppose draw a right. Okay, right. This is 0, this is 2, and so on. This is time second. 1, 2, 3, so on. Roughly we take 5, 10, 20, so. And so on, right? So this is the time in second, this is distance in meter. Distance in meters. Okay. Right. Here, what does uniform speed mean? Uniform speed. If an object, I'll present the definition first, then we'll go for the discussion. Here, an object travels equal distances in equal intervals of time. Intervals of time. Then we say the object is moving with uniform uniform speed, right? So very simple definition, as simple as it is. Right, okay, students. So here we have taken a graph here. Okay. So as for the graph, we have taken time on the y-axis. So this is y-axis, you know, y-axis, sorry, x-axis, and this is our y-axis. Y-axis. Right. So on the x-axis we have taken time, and on the y-axis we have taken the distance traveled. So if we see for 1 second the object. Okay, let us plot a point here. Okay, 1 second how much it has traveled? Okay, 5 meter, 5 meter. Okay, next 2 seconds it has traveled how much distance? So let us see. This is somewhere. The point is coinciding. Right. Then for the next second, that means in 3 seconds, how much you have traveled? So that is, yeah, marking a point. Okay. So that's if we draw this, join this, it's coming something like this. And then finally, for 4 seconds, is something like this. So dear students, if you see here, okay, and so on, okay, it is so on. So we have a graphical representation of the data. See, wait, we try to understand what is the uniform speed. So by definition, what is the uniform speed? See, if an object travels equal distances, what is that? Equal distances in equal intervals of time. Then we say the object is moving with the uniform speed. So what is the general speed from the average speed? Generally we have discussed yesterday. It is equal to distance by time. So the average. That is, we have the formula already. So now, if we calculate the speed at every interval of time or every instant of time, let us see how much the speed is coming. So 1 second 5 meter. So 5 meter in 1 second. So that is equal to 5 meter per second. Next 2 seconds. It has traveled 10 meters. So here at the first instant, first interval or first interval. Okay, during the second interval, it is 10. Okay, so 10 meter in how many seconds? 2 seconds. Okay, 2 seconds. So that is once again 5 meter per second. So at the third instant, at the third interval, at third second. So it is 15 meter in 3 seconds. 3 seconds. 5 meter per second. And then at the fourth instant, fourth interval, Okay, students, have you seen this? Right. We have taken a few intervals and so on and so on. So as it is moving, its speed will not change. Its speed will not change, which means that at every interval of time, it is covering equal distances. In 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds. Right? So at the end of the first second, let us calculate the speed. So 5 meter in 1 second, 5 it is nothing but 5 meter per second. Right. Then in the second interval of time is the next second. So that means at the second interval, it has traveled. So second interval, how much distance it has traveled? Let's just let us look at the graph. So second it has traveled. What is that? 10 meter. Okay, 10 meter. That is 10 meter and time is 2 seconds. So 10 by 2, 5 meter per second. Finish. So the value is same. At the third instant, the third second, okay, 50. So 15 meter in third 3 seconds. 15 meter in 3 seconds. It is nothing but 5 meter per second again. And finally, at the fourth interval of time, it has traveled 20 meter in 4 seconds. So calculate that it is coming as 5 meter per second. So everything is fine. Okay, guys. So when is this possible? When can an object perform or move in a uniform speed? Any guess? Right, I'll tell. Okay. So when can an object have such a situation means when and only if and only if and only the path is straight. Path is straight. And another case is also there, that is path is circular also. Okay, circular also. That is different case. We will discuss after. So almost so only maximum possibility is okay. Maximum possibility is the two conditions. But only the path is straight only. So these values are possible. Out of these values, just for our understanding, I have kept the values. You can give any other value also, no problem. But it should cover equal distances in equal intervals of time. Understood, students? So once again, I just repeat this. So uniform speed is an object travels equal distances in equal intervals of time. Then we say the object is moving with uniform speed. Right. So this is how we can understand the concept with the help of a graphical data. Okay. As it is a scalar physical quantity, we don't mention the direction also. As it is a scalar physical quantity, we don't mention the direction. Only we have mentioned the magnitude. That's all. Okay. So we move to the next topic, that is instantaneous speed. Now, instantaneous speed. So instantaneous speed. So instantaneous speed. Let us see the definition first. Right. Right, students. So let us see the definition first now. So the speed of an object at a particular instant, okay, at a particular instant, at a particular point of time, or a particular period of time. Okay, so as we have discussed, an object is traveling in a particular direction or particular path, and it is in particular time intervals, it is covering so and so distances. Now we have discussed already what is meant by uniform speed, and now let us see what is meant by this instantaneous speed. Instantaneous speed, the word itself is saying that at a particular point of time, at a particular instant of time, what is this speed? So let us try to understand, okay, from simple terms. Suppose if I need to find the speed of the object at a particular instant, suppose at the end of 3 seconds. So just okay, right? So I draw this and just I try to drawing this one. Okay, so this is a straight line bisecting the angle. Okay, right line bisecting the angular bisector. Right. So in the okay, so we see a straight line here. Now, if I need the speed of an object at a particular interval of time, so at this point of time, if I need, just I draw the slope. Okay, just the slope of the slope. Slope of the triangle, okay, gives the instantaneous speed. So what does the slope give? It is nothing but the y component, by x component. Okay, y component by x component. What is the y component? So this is nothing but 3, and this is nothing but 3. So 3 meter per second is 5 meter per second. So this is the instantaneous velocity at this point of time. Suppose if you need any instant. Suppose if you need to calculate the speed at this particular instant, suppose 3.5. At the 3.5 second, somewhere you will get the slope. You draw the slope, just you get a slope line. Okay, okay, students. So this slope gives you that is this point 5. Okay, so this component, that is this y component by x component. So that is nothing but okay. What is that we are getting here? At the end of 3.5. So 15.5 by 3.5. That's all. So at any instant, not only there, wherever. Okay. So what happens is it becomes a very small value. Okay, it becomes a very small value. Suppose here it is a straight line. Suppose if it were a graph, if it were a curved line, if it were a curved line. Okay, suppose we get some curved line like this. So then what is the instantaneous velocity? Suppose we need the instantaneous velocity at a particular point B. So the slope or the tangent, see, this is the curved line. This is the curved line, and the tangent at a particular 2 points. Okay, tangent at a 2 points gives us the instantaneous velocity. Okay, the tangent at a 2 points. So this is 1 point, and this is another point. Right. So now the slope gives us the instantaneous slope gives instantaneous velocity. Okay, as it is very small value, as it is very small value we get. Okay, we get it as differential quantity. So that is nothing but dv is equal to a small distance dx by dt. Okay, so as we are making it a very small value, very small. Okay, so as it is very small value, okay, we differentiate it. This differentiation This you will learn in your later classes, my dear students. So don't panic or don't no need of confusion. As this is a very small value, we are expressing it in terms of dx by dt, which is nothing but unit is same. So this meter per second. So that is about instantaneous speed. Suppose if we have a curve like this, okay, we are not discussing about uniform speed. Suppose the motion of the object is like this, we get a curve like this. So for a curve, okay, 2 points, okay, 2 points. So this is the tangent. Okay, this is the tangent. You know this very well. You know the concept of tangent. Okay, you can draw a tangent for any curved surface. So like that, the tangent or the slope gives us the instantaneous velocity of that particular object. So actually, this is the basic concept. But when we come into the practical usage, suppose if a vehicle is moving at a particular value of speed, suppose 60 kmph, 65, 70 kmph, something like that. So if we need, suppose if the vehicle is in journey, that means if it is in motion, then to find the instantaneous speed, the speedometer of the vehicle gives. Okay, what is that? Speedometer. Speedometer. So how can you find the instantaneous speed of the object? With the help of speedometer. Okay. Yeah, generally an instrument will be present in every vehicle, whether it is a bike, car, lorry, whatever. Okay, it will be indicating the speed. Just if you look at the speedometer, the arrow, whatever it is showing the value, that will be the instantaneous speed of that particular vehicle or the object. Understood? Understood, students? Okay. So this is the concept of instantaneous velocity. Suppose we get a curve. We get a curve between what is that? Distance and the time. We get a curve. So in such an instance, the instantaneous velocity at a particular point of time interval, at a particular point of time interval. Okay. So that we draw a perpendicular to the x-axis and y-axis and whatever the points that are there. Okay, we get the instantaneous velocity by dividing this y component by x component. As it is very small value, we use the differentiation here. So dv is equal to dx by dt. That gives us the instantaneous speed of that particular object. Understood? Okay, hope you understand. Next, we will move to the next topic, that is velocity. Okay, so totally. So let us discuss now velocity. Velocity. So like what we have discussed, the speed is average speed, and then uniform speed and instantaneous speed. Instantaneous speed. Like the same manner, we have also simply not velocity, but we have average velocity. Average velocity, uniform velocity, and instantaneous velocity. Instantaneous velocity. Instantaneous velocity. So, what did we define for average speed? What did we define for average speed? That was nothing but the distance, total distance by total time taken, total time taken, total time taken. The same manner, we define average velocity as the ratio of total displacement of the object. Total displacement to total time taken. Total time taken by the object. Is called average velocity. Average velocity. So very simple concept. Very simple concept. Okay. So as we have discussed, it is almost similar, but here only difference is this is a scalar. This is a scalar, and you know very well this is a vector. This is a vector. Physical quantity. So, dear students, look at the definition now. So, the ratio of total displacement to the ratio. It is a ratio. We are dividing one quantity by another quantity. That is nothing but the ratio. The ratio of total displacement to total time taken by the object is called average velocity. Suppose, let us think that an object has started from this point. Like this, it has traveled to a particular another final point. Okay. So initial point is P and the final point is Q. This is the original distance. Original distance traveled by the object. Now we draw the displacement for this one. So total displacement. So this will be the displacement. Okay, this will be the displacement. Now let us try to read the definition of displacement. Once again, that day we have discussed this. Yes or no? Right. So the shortest distance, between the initial and the final point, the shortest distance. This is right. The shortest distance. This could only be the shortest distance between these two points. There is no other possibility. Not like this or not like this. Not like this. So the shortest distance between the initial and the final point in a specific direction. Is called as the displacement between those two points. Okay, the shortest distance. So this is the shortest distance in a specific direction. So this is the specific direction. Suppose this is some around 20 centimeter. 20 centimeter. Okay. So suppose now this is a particular direction. So here we have this as, so this is north, east, west. Okay. So right. So if we represent this here. Okay. This is north. Okay. So this is east, west, east. Okay, as we are placing this, so this distance here, like this means the board is like this. So here it is coming like this means something it is coming like this. So northwest, or simply we draw like this, westwards. Okay, right. So something northwest, 20 centimeter northwest. So this is the displacement of the object. Students. So look here carefully once again. So while defining average velocity, how do you define it? The ratio of total displacement to total time taken for the object. Okay, 20 centimeter per second. Okay, per second. 20 centimeter per second. Northwest. Okay, northwest. So the ratio of total displacement to total time taken by the object is called average velocity. An object has started from P, like this it has traveled up to Q. This is the original distance traveled, and this will be the displacement of the object. And Now, suppose we express it in a particular value, we get the displacement. So it is nothing but 20 centimeter towards northwest, 20 centimeter towards northwest. So there is one other relation between these two. Let us discuss. That is nothing but magnitude. Okay. So magnitude of velocity, magnitude of velocity is speed. Magnitude of velocity is speed. Magnitude of velocity is speed. Very, very important point to be noted. So magnitude of velocity is speed. Actually, how do you denote this one? So we denote this one as v bar. So v bar, and this one as simply speed as just v, because as it is a scalar, as it is a vector, we denote with a bar. That means an arrow mark which indicate that the physical quantity is a vector physical quantity. So by taking the modulus, so is equal to v. And similarly, if we speak of the same thing regarding displacement and distance, so here also we get the same thing. That is magnitude of displacement is distance. Displacement is distance. So that means mod s bar is equal to s. Mod s bar is equal to modulus of s bar is equal to s. So that means here, okay. So what do we have? We have velocity here. What is the value of velocity? 20 centimeter, 20 centimeter per second due northwest. So what is the modulus of velocity means here? We just speak of only the value under unit or the number of the unit. So this becomes the magnitude. Already we discussed the concept of magnitude earlier, okay, in detail. So 20 meter per second is the speed. So this indicates the speed or magnitude. Okay, magnitude. So this is the magnitude of velocity. Magnitude of velocity is nothing but the speed. So with this much of speed, it is traveling in what direction? Northwest direction. It is traveling in what direction? Northwest direction. Okay, dear students. So are you following this? Okay. So what's the name? Average velocity. It is nothing but the ratio of total displacement to total time taken by the object is called average velocity. We denote it as, okay, v bar is equal to, okay, displacement by time. So that is s bar by t. This is the vectorical representation of velocity, average velocity, v average. Okay. So vectorical representation of average velocity like this. Understood? Okay. Next we go into this next concept, that is uniform velocity. Uniform velocity. Okay, students. Now let us see what is meant by uniform velocity. Uniform velocity. The same thing like what discussed, we have discussed for speed. Okay, if the speed, sorry, if the distances traveled by an object is same in same intervals of time. Okay, if an object is traveling equal distances in equal intervals of time, then we say that the object is moving with uniform speed. Now we assign direction to that. Okay, once we assign direction to speed, then it becomes velocity. Let us see. With the okay. Right. So here, as one, two, three, four, five, and so on. Time in, and this is x axis, and this is y axis. 1, 2, 3, 4, 5, and so on. Similarly, we take this 5, 10, 15, 20, 25, and so on. Okay. So this is distance in meter, distance in meter, and this is the starting point, 0 point. Okay. So here, the same way as we have discussed, okay, what is uniform velocity definition? If an object travels equal displacements in equal intervals of time, it is moving with then it is moving with then it is moving with uniform velocity. So this is the definition. This is the definition for uniform velocity. So students, so they have used here. So the definition for uniform velocity: if an object travels equal displacements in equal intervals of time, then it is moving with uniform velocity. So we have taken a graph like this. So suppose if the same thing once again. So if you look at this. The line joining the points here, okay. So points suppose P, Q, R, S, etc. We get a straight line. We get a straight line or the angle bisector. What is that? The angle bisector. So whether it is uniform speed or uniform velocity. Okay, uniform velocity. If the object is traveling with equal displacements in equal intervals of time. See, 1 second, 5 meter, 5 meter, and then 2 seconds, 10 meter, 3 seconds, 15 meter, 4 seconds, 20 meter. So the displacements are same. So that means the object is covering equal displacements in equal intervals of time. So let me say that it is moving with the uniform velocity. So how do we represent this? So that is nothing but d bar. Once again, it is same as x bar s bar by t, s bar by t, s bar by t. So vectorical representation of uniform velocity. Once again, the SLVT is meter per meter per second. The concept is same. Okay, we assign the direction. Okay, suppose the object is moving with the so 5 meter per second due east. Due east. Understood now? Okay. So at any instant. So once again, the concept of instantaneous velocity also same now. So if you have understood the concept of instantaneous speed, then the concept of instantaneous velocity is also same. But only thing is we should speak about direction also. The object is moving with a particular value of speed. Then we are speaking about direction. In which direction it is moving? Then we are speaking about velocity. Okay, we are assigning the direction, then we are speaking about velocity. If you are not assigning any direction, then simply the value speaks about speed only, speed of the object. So let us see about uniform velocity. Now, as the time is passing, that means at a particular interval of time, the value of the distance covered by the object is same. Hence, we say that it is moving with what? Uniform velocity. It is moving with uniform velocity. So if an object travels equal displacement, so this is important. Okay, equal displacements in equal intervals of time. Equal intervals of time. So this is also possible when the path is straight. Okay, even this is also possible only when the path is straight. When the path is straight. When the path is straight. So this condition is very important, students. Just have a note at this. Okay. So very clear, very clear. When a particle, of course, for uniform speed to happen, there are two cases. The path can be straight and also path can be circular. That is two. Okay. Two possibilities are there. But here, no other condition. Only thing, the path must be straight. The path must be straight. And then, when do you say that the velocity of an object has changed? So why, sir? You may get it out. Sir, you have told that for a circular path, that means if the object is moving in circular path with a constant speed, okay, that also comes under uniform speed. But why you can't say that as an example for uniform velocity that we will discuss now? Why the velocity we can't say for that example? Okay, so understood this one now. Uniform velocity, okay, displacement, equal displacements in equal intervals of time. Then we say that it is going with the uniform. Okay, instantaneous velocity now. So at a particular instant of time, you take the slope. Okay, so this slope at a particular interval of time, we use the so y component by x component will give you the value of instantaneous velocity. Suppose that is given as the same thing, delta x or dv. So dv. So instantaneous velocity is given as dv is equal to ds by dt. So very small value. This is a very small value. We write it like this. Okay, dv is equal to ds by dt. So that is about instantaneous velocity. So now let us discuss at what are the instances the value or velocity changes. So when do you say that velocity of an object has changed? Very important concept to be understood and to be digested. Okay, as long as you study physics, you should know when a vector is said to be changing. When a vector I am saying, so this is applicable for all vectors. So now we are discussing about velocity, of course, but generally, when do you say that? For example, vector displacement. When do you say that the displacement has changed, or when do you say that velocity has changed, or when do you say that force has changed? So all these things, it is applicable for all the things. So let us see now discuss about when do we say the velocity of an object has changed. Okay, the velocity of an object has changed. So what are the conditions? We say that the velocity of an object has changed. Okay, we will see now. So, what are the situations in which we say that the velocity of an object has changed? So, first condition is when the magnitude changes. When the magnitude changes. Second one, when the direction changes. When the direction changes, and finally, and the final condition is when both magnitude and direction changes. We say the velocity of an object changes. The velocity of an object changes. Right. So students, look at this carefully. So when do we say that the velocity of an object changes? So the velocity of an object changes at three situations. We say that the velocity of an object is changed when its magnitude changes. So that means these three conditions all need not be applicable. Any one of these. Okay. So any one of these situations happens. Okay, any one of these situations happens, then we say that the velocity has changed. Okay, are you getting? So these three are, it is not compulsory that all the three has to occur. Okay, all the three has to occur, but any one of these happens, then we say that the velocity has changed. For example, an object is, okay, what is the first condition? Magnitude. Okay, magnitude. An object is moving at a speed of 35 kmph, 35 kmph due north. Okay, 35 kmph due north. Okay, now, so as per our condition, the magnitude has to change. So the object has changed. That means after some time, its magnitude changed to 40 kmph. Same, not direction. Have you noticed the difference now? So initially it was 35 kmph. Okay, now it changed to 40 kmph. Now, did you see the number has changed now? Okay, 35 became 40. 35 became 40. So, or any other number. You can take any other number. Okay. So, when the magnitude changes, when the magnitude changes, you can take any n number of examples. Understood? So, if the magnitude changes, we say that the value of or simply velocity has changed. Okay, second case. First case is over. Now, second case, the direction changes. Now, look carefully. Say, the object was moving with the okay, 35 kmph, 35 kmph due north. Okay, now its direction changed. It changed its direction. So that means now it is traveling the same speed, 35 kmph due south. Due south. Now its direction is towards south. See, the value of magnitude did not change. The value of magnitude did not change. What did change? What is the change? Only in direction. So here the value of magnitude changed. We said that velocity changed. Now second case, the direction is changed also. We say the velocity has changed. Any one of these three. Okay, be careful. So, once again, listen carefully. So, it is not necessary that all the three has to occur, but any one is sufficient. Any one is sufficient to say that the value of velocity has changed. Understood, students? So first case, second case, then the third case. So let us see both magnitude and the direction changes. So let us say that the object was moving with 50 kmph. 50 kmph is okay. 50 kmph is so it changes to 70 kmph. 70 kmph not 70 kmph not. Okay. Now you look here. Both the value of the number is changed as well as the direction is also changed. The number has changed and the direction also changed. So initially it was moving with the value, that means with the velocity of t kmph towards east. Then it changed its direction as well as the value of its velocity. So it is nothing but 70 kmph north now. Okay, 70 kmph north now. So both magnitude as well as direction, both magnitude as well as direction has changed. So 50 kmph became 70 kmph and then east became north. Okay, so initially east and then north. So it took a right turn. Okay, right. So these are the conditions where we say that the velocity of an object has changed. Understood, students? So totally three situations. So when magnitude changes, velocity changes. When direction changes, okay, when direction changes, velocity changes. When both magnitude, when both, okay, both magnitude and direction changes. Magnitude and direction changes. We say that the velocity of an object has changed. Okay, so totally three conditions. All three not necessary. If any one is satisfied or if any one is happening, then we say that the velocity has changed. That is why the reason for a object which is in circular motion, the object which is in circular motion with uniform speed. Okay, with a uniform speed. Suppose this is a circle. Okay, so the object is moving in this direction. So means anti-clock direction. Okay. Now, if we calculate or if we try to assign, okay, so suppose let us assume that speed be 2 meter per second. 2 meter per second. Suppose a point on the wing of a fan. Point on the wing of a fan. Suppose if you mark a point on the wing of the fan. Okay. Now that point will be in constant motion when you switch on the fan. Its speed will be constant, but direction is not constant. But direction is not constant. Suppose if you see at this point, okay, at this point, the direction of velocity is like this. The direction of velocity is like this. So 2 meter per second it is okay. So this is south. So now the same point, suppose it is okay at here. So that will be the direction has changed. The same value. Then if you look at here, this is the direction of velocity of that particular object. So this is 2 meter per second u. What is this direction? This direction is exactly opposite of east is west. Okay, and then at this point it is okay. Once again, 2 meter per second it is north. Again, finally, you have to calculate it here. At this point, the speed is or velocity is okay. Same value 2 meter per second. Okay, is east. Okay, students. So this is the reason why we say that for an object in a curvilinear motion, for an object in a curvilinear motion, the velocity is not same. At this point, if an object is moving like this in a curvilinear motion, at this point, the direction of velocity is like this. At this point, the direction of velocity is like this. At this point, the direction of velocity is like this. And again, at this point, the direction of velocity is like this. At this point, the direction of velocity is like this. Okay. So these are the conditions. Okay. So these are the conditions. So when the velocity changes, the direction changes. So when the direction changes, the velocity changes. So this is the These are the directions of velocity. So this is the direction of velocity at this point. See, the object is moving like this. Okay, the object is moving in a circular path at different points of time. As the direction changes, that's how we have discussed. What are the three conditions? When the direction changes. When the direction changes, we say the velocity has changed. Okay, so for an object which is moving in a circular path, an object which is moving in a circular path, we say that maybe the speed is constant, but the velocity is not constant. I hope you understood the concept, students. Okay, thank you for listening. We continue in the next class, that is acceleration, and then equations of motion.